Alright guys, in this video we're going to be talking about molecules and bonds. And not James Bond, but close enough. What is a molecule? Well, molecules are just two or more atoms bonded together or combined together. Okay, we've been talking about individual atoms up to this point, but when you combine them together to form new things, we call that a molecule. And molecules are written out in what we call a molecular formula. For example, this is a molecular formula for water. So let's break down what a molecular formula is. Molecules. So molecules are written out with a molecular formula. Each element in a molecule starts with a capital letter from the periodic table. For example, this is hydrogen and oxygen. Oh, I can't spell. Oxygen. So water is made up of two different elements, oxygen and hydrogen. Okay, the small subscript on the numbers tell you how many of those atoms there are. So right here we have the subscript 2 on the hydrogen to tell us that there are 2 hydrogen atoms. And they are combined with 1 oxygen atom. The reason why it's 1 oxygen atom is because there's no number right here on that subscript. If there's nothing there, that means there's just one of them. Okay, so water is made up of 2 hydrogens, 1 oxygen, and they are combined together to form a water molecule. Okay, sometimes molecules are written with parentheses. And what that means is everything inside the parentheses is being combined with each other, and everything in the parentheses are bonded to the things outside the parentheses. For example, nitrogens and 3 oxygens are being combined with the barium, the Ba. Okay, now if there's a number outside the parentheses, that means there are 2, or in this case 2, of everything inside of the parentheses. So there's not 1 NO3, there's actually 2 NO3s, which means there's not actually 1 nitrogen, there's 2 nitrogens and 6 oxygens. Now the easy trick is you'll just take the subscripted number and you'll multiply it by the subscripts of everything inside it. So 2 times 3 to make 6 oxygens, and 2 times 1 to make 2 nitrogens. So that's the simple way of figuring out how many of each atom you actually have. Oh, this subscript only goes for the things in the parentheses. The barium is by itself. If there was 2 bariums, we would put a 2 right here. In this case, there is none, so it's just a 1. Okay, so here's some just random examples. This is a molecule with 2 calciums, 4 bromines. Here's another molecule with 1 carbon and 4 hydrogens. So just a few other examples of molecules and figuring out how many atoms you have combining. Okay, we're going to take a step back to something we've already learned about, the octet rule. The octet rule says that atoms want a full outer shell of stability, or a full energy level of electrons. Okay, in the first energy level it's 2, after that they want 8 electrons. Okay, we have learned this. Atoms will gain or lose electrons to get a full outer shell. For example, sodium here has 1 valence electron, and if it just loses that single electron, it will have a full shell of 8 electrons. The only thing that's going to change now is sodium is left with a positive charge. We call that an ion. So sodium is now a positive ion. But now it is satisfied. It has the full octet. Okay, so what this leads us to is finally bonding, which is really probably the most important part of chemistry, is understanding how bonding works. So what is a bond? It's just a force that holds 2 or more atoms together. They form when atoms try and complete their outer shell of electrons. So it's all about electrons, where are the electrons going, and how do these atoms combine with each other because of these electrons. So there are three types of bonds, and one of those bonds is broken up into two types. So we've got ionic bonds, covalent bonds, and metallic bonds. And covalent bonds are broken up into two different types called polar and nonpolar. Another important thing is to understand that ionic bonds are the combination between a metal and a nonmetal. Covalent bonds are between nonmetals only, and metallic bonds are between metals only. So looking at this little chart here, the periodic table is broken up into pretty nice sections of what are metals and nonmetals. So your metals are these red elements over here. They're on the bottom left of the periodic table minus hydrogen. Hydrogen's right here. It should be a nonmetal. And then these over here are your nonmetals. So these are a good indicator of determining what type of bond will form based on if it's a metal or a nonmetal. For example, if I could just pick a random one, potassium is a metal, it's right there, and chlorine is right there, that's a nonmetal. So this should form an ionic bond because it is a metal and a nonmetal. If I combine carbon and oxygen, okay, those are both nonmetals, so it should form some sort of covalent bond. And if I just have like iron, or maybe it's iron and nickel, maybe it's iron, nickel, and copper, okay? Since they're all just metals, they're going to form metallic bonds. And that's how I can kind of identify which type of bond I'm going to get. Now, breaking it up or looking more in depth, let's see what an ionic bond is. So an ionic bond, which we've already talked about, is between a metal and a nonmetal, is when atoms exchange electrons to complete their outer shell, or they transfer electrons. Now, what happens when they transfer electrons is these atoms are left with a charge. They become ions. And when an ion that is positively charged and an ion that is negatively charged combine, they will form an ionic bond. So here's that example of an ionic bond here. We got sodium. It's going to lose its one valence electron and give it to a chlorine. When it does that, the sodium is left with a positive charge right here, and the chlorine is left with a negative charge right here. And when these positive and negative charges get close, they're going to form an ionic bond. That positive and negative forces will attract each other. This is table salts. Table salt is formed because they form ionic bonds, sodium chloride. Okay, so ionic bonds, they're considered an electrostatic attraction between the positive and negative parts of these atoms. This happens because they transfer electrons, and these will happen between metals and a nonmetal. All right, covalent bonds are different. Covalent bonds don't transfer electrons, they share electrons. Electrons are being shared between the atoms. Okay, these will only happen between nonmetals. Here's a good example. This is carbon dioxide, actually. Carbon dioxide is made up of carbon and two oxygens. They're all nonmetals. This section right here tries to show this bond and show that atoms are sharing electrons. This oxygen is sharing with this carbon, and they're sharing about 4 electrons. And this oxygen and this carbon is sharing about 4 electrons. So this is what covalent bonds are all about, and there's two different types. There's a polar covalent, where it's unequal sharing of electrons, and then we'll talk about the other type later. Polar covalent bonds will happen because there's different nonmetal atoms, and one of them is going to have a higher electronegativity. Remember, electronegativity means that they are attracting other electrons outside the atom. So between hydrogen and chlorine, if we look on the periodic table, chlorine is much closer to the top right of the periodic table, so they must have a higher electronegativity. And because of that, it's going to pull electrons closer to the chlorine side and make it more negatively charged over here, leaving the hydrogen side more positively charged. We call this a dipole. A dipole is where we got one side of the atom that's negatively charged and the other side that's positively charged. So this would make it a polar covalent bond because of this dipole that exists. And this happens, the way to identify it is we have two nonmetals with different electronegativities bonding to each other. Okay, nonpolar covalent, that's what we call equal, or what happens when we have equal sharing of electrons. These will happen because these are the same nonmetal elements, or they have similar electronegativities. Electronegativities. That's such a long word. Okay, if they have similar electronegativities, especially if they are the same elements, they will share equally, which means I don't have a dipole. These electrons are shared directly between each other, and there is no positive or negative side onto that molecule, but rather equal sharing throughout. So this is a nonpolar covalent. The final type of bonds are called metallic bonds. Okay, these will only happen with metals. It could be more than one metal, which would be called an alloy, or it could just be between one type of element like pure gold, which we would just say is a metal. Okay, now we consider the type of bond a sea of electrons. What happens is these valence electrons in the metals are free to flow throughout this area. These are the actual atoms. Think of this as iron atom, another iron atom, another iron atom, another iron atom right here. And they just have electrons that flow throughout. We call it a sea of electrons. These electrons are allowed to flow wherever they please. And that is why metals are really good conductors of electricity, because of these electrons that just get to flow throughout. So it's much different between the other types of bonds. As a quick summary, ionic bonds transfer electrons. Covalent, whether it's polar or nonpolar, share their electrons. It just might be pulled one side more than the other. And then there's metallic bonds where electrons are free to flow everywhere. So the bonds are all based on what's happening with these electrons and how these atoms are being held together. Okay, that's it. That's everything. If you have more questions about bonding or molecules or how to write molecular formulas, just ask Mr. Steppen or I, and we will be more than happy to help you.